The best image that they offered at the press conference indicated that there is fuzz elongated.
A NASA insider has confirmed what many feared. 3I/A TLAS is actively maneuvering in space. It is not following any natural pattern, and the course adjustments are too precise to be random. This object is behaving like something guided, something aware of its surroundings. Experts are trying to understand how an interstellar body can shift direction without any known propulsion signatures. The discovery has raised serious concerns and forced new questions that no one feels ready to answer. If 3I/A TLAS is truly maneuvering with intent, then its purpose and its destination could change everything. The strange shift of 3I Atlas. On the first day of July in the year 2025, the Asteroid Terrestrial Impact Last Alert system detected a tiny, faint point moving across space at a speed greater than 42 kilometers per second. That single measurement told astronomers exactly what kind of object they were observing. Anything traveling that fast could not have formed inside our solar system. It had to be an interstellar visitor, something that began its journey in a completely different star system. Before this discovery, only 2 confirmed interstellar objects had ever passed through our solar neighborhood. The first was the long, narrow object called Oumuamua, seen in 2017. The second was 2I Borisov, a comet observed in 2019. Both behaved exactly as expected. They moved along clean gravitational paths, curved smoothly around the Sun, and continued onward without causing confusion or unusual effects. They came and went like quiet guests who follow every rule. 3I Atlas, however, did not follow this familiar pattern. From the moment it appeared, something about it felt different. Its path cut through the solar system at an angle that no planet or moon could have produced. Computers at the Jet Propulsion Laboratory calculated its route and confirmed that it was following a perfect hyperbolic trajectory, the kind of path traced by something passing through only once before returning to deep space. Every telescope pointed at it over the following months confirmed those calculations with impressive accuracy. The object appeared exactly where it was predicted to be, at the precise moment it was expected to arrive. Then everything changed. By the middle of October, observatories around the world began reporting unexpected differences. 3I Atlas was no longer appearing at its predicted coordinates. The independent research group Earth Exists captured new images, and the object was not just slightly off course, it was far from where the models placed it. The shift was more than 15 minutes. At its distance, this meant a sideways movement of about 1.1 million kilometers. That distance is nearly 3 times the space between Earth and the Moon. No natural object drifts sideways like that without a clear, measurable reason. Every natural body in space, from tiny dust grains to large comets, moves according to the strict rules of gravity. When something drifts even a few hundred kilometers away from the expected path, scientists recheck their calculations. But 3I Atlas had shifted more than 1 million kilometers sideways while keeping its exact distance from the Sun, almost as if only part of its motion had been altered. The Earth Exists team performed every test available to them. They compared their star maps against the most accurate catalogs. They synchronized their atomic clocks using precise network systems. They recalibrated their cameras using dark frames and bias corrections. Every test confirmed the same result. The measurements were accurate, the observations were real, and the object had moved into a position it should never have reached. What made the situation even stranger was the direction of the shift. When orbital models fail, an object usually appears behind its predicted position, because earlier estimates often underestimate its speed, but 3I Atlas was ahead. It had moved several arc minutes beyond the allowed point. To reach that location, something had pushed it sideways with tremendous force. At interstellar distances, Shifting even a few kilometers per second sideways requires an enormous amount of energy. For a large, icy object, scientists recognize only two natural explanations: strong jets of gas bursting from its surface, or the gravitational pull of a nearby massive body. But spectroscopic data showed that its outgassing was normal and steady, with no unusual eruptions or violent releases of material. The pattern that should not exist. The divagation was not arbitrary, and the change did not slow down. It kept increasing. By the end of October, the gap between the predicted position and the real position was growing at a rate that could be measured clearly. The object was drifting sideways with a steady acceleration of about 0.23 arc-minutes each day. This sideways motion was smooth, constant, and intentional in appearance. It looked nothing like the uneven movement that scientists normally expect from a natural comet. Experts explored every ordinary possibility they could think of. They questioned the spectroscopic readings and wondered if small, hidden bursts of gas were pushing the object in unexpected ways. They also asked if the orbital models had a mistake. Some even considered whether atmospheric distortion was creating false signals in the telescopes, but each idea failed as soon as it was tested. The spectral lines stayed clean and stable with no sign of error. The updated orbital calculations, completed less than 2 weeks earlier using the most advanced software available, showed no flaws. Telescopes in different parts of the world recorded the same movement, confirming that the shift was real and not caused by a single faulty observation. All the collected data pointed toward a pattern that worried many scientists. The object was not drifting randomly, and it was not spinning in a wild or natural way. Instead, it maintained a precise distance while sliding gently to one side, almost as though something invisible was guiding it along a new path. The motion was sharp, controlled, and steady in a way that did not match any known natural behavior. On top of this, tiny distortions appeared in the reflected light. These distortions suggested the presence of organized magnetic fields surrounding the object. Computer simulations showed that such patterns only appear when ionized gases are being contained or guided, not when they are free to spread out in a natural flow. If that interpretation was correct, then 3I Atlas was not only moving in an unusual manner, but also shaping the space around it with a level of order that comets should not create. Another troubling detail came from its brightness. Comets normally grow brighter as they get closer to the sun. When solar heat melts their ice, the released gas and dust reflect more light, causing a stronger glow. This is one of the most consistent rules in astronomy. But 3I Atlas behaved differently. As it approached the sun, it became dimmer instead of brighter. Instruments confirmed that it was releasing more material than before, yet its brightness continued to fall. Based on data from JPL's Horizons database, the object should have had a magnitude of 14.83. However, measurements showed a magnitude of 15.12, making it about 26% dimmer than expected. In astronomy, a change that large is considered significant. It meant the object was reflecting only a fraction of the light it should have reflected. The missing light could not be blamed on distance, viewing angle, or equipment limitations. Something was absorbing the light or redirecting it in a way that did not match normal behavior. The colors in the light from 3Y Atlas caused even more concern. Engineers experienced in spectral analysis noticed that the glow was not the usual blurred and uneven shine seen in most comets. Instead, the light appeared in clear, organized bands. Green came from cyanogen molecules, blue from ionized nickel, and faint pink from hydrogen interactions. Each color appeared in exact, separate zones with sharp boundaries. It looked as though invisible barriers were dividing the gases into clean layers. This clean separation had no ordinary explanation. Natural comets produce mixed and scattered colors because their gases swirl and collide freely. But here, the gases were arranged in a way that suggested structure, order, and control. The entire behavior of the object, its sideways drift, its falling brightness, its organized magnetic patterns, and its neatly layered colors, pointed toward a process that did not match the usual nature of a comet. The structure no natural object should have. When the high-resolution images from the telescopes in Chile finally arrived, they revealed something that should not exist on any natural object. The images showed real geometric structure where no natural form should appear. Under digital enhancement, the object known as 3I Atlas displayed sharp, clearly defined edges in places where a comet should only show soft and fading boundaries. Its core did not blur outward the way every known comet behaves. Instead, it was divided into clear and separate multicolored regions that held their positions as if each section had been arranged with intention, almost like components placed together with careful design. The outermost layer glowed green with the presence of cyanogen, a chemical commonly found in comets, yet never arranged in such a neat and confined ring. Inside that bright outer glow sat a vivid blue region that pulsed with the light of ionized nickel. At the center rested a strong white-yellow core burning with steady brightness, surrounded by a pink directional halo that pointed outward in consistent form. None of the colors blended the way natural emissions usually do. Every part kept its shape, as though some hidden electromagnetic boundary prevented the layers from mixing or softening. To confirm that these strange shapes were not caused by distortion or optical tricks, analysts compared the exact same field of view to two control objects captured under identical telescope settings. The bright star spiker appeared exactly as expected, a clean and steady white point, Comet C/2025 R-2. Swan showed the typical uneven, irregular glow seen in natural comets of its type, but 3I Atlas resembled neither of them. Its sharp geometric layout remained visible night after night. Different telescopes, locations, and filters continued to show the same structure, removing the possibility that it was a one-time observational fault. Spectroscopic analysis raised even more questions. The hydrogen emission line, normally the strongest and most stable feature in any comet, was shifting in a pattern that no natural process could produce, the oscillations repeated every 4.3 seconds with perfect and unbroken precision. No rotation pattern, gas venting cycle, or fragment shedding process behaves like that. The signal looked controlled, almost as if the object was adjusting the intensity with deliberate timing. While ground-based observatories continued studying the unusual patterns, NASA's LASCO Solar Telescope detected something unexpected. On the 20th of October, the SOHO spacecraft, which constantly monitors the Sun's outer atmosphere, recorded a brief object passing across its field of view. It flashed with a cross-shaped burst of light, disappeared, and then reappeared in another frame, smaller and sharper. Most experts dismissed this as a detector artifact caused by charged particles striking the sensor, but an independent researcher, David Sarita, noticed something unusual when he compared the frames to the known position of 3I Atlas. The cross-shaped form matched almost perfectly. The timing and direction of movement aligned as well, raising questions about whether the image truly was an error. When the SOHO frames were processed side by side with the ground-based images, the match became even clearer. One set captured faint coronal light, and the other captured visible light from Earth, yet both pointed to the same repeating pattern around the object. Only hours after that solar observation, Earth's magnetic field began swinging violently. A G4 geomagnetic storm struck with almost no warning. Strong X-class solar flares had erupted the previous day, and the storm disrupted radio signals across North America and disabled several satellites for hours. The upper atmosphere is filled with electromagnetic interference, strong enough to distort telescope readings and sensor outputs. The timing created serious concern. If 3I Atlas carried any sort of electromagnetic field, The solar storm would have acted like a massive surge. Under such conditions, the light around the object could intensify, fade, or change shape. The LASCO data showed exactly that behavior. The pulses of brightness matched the timing of the solar flare with remarkable precision. Some experts called it coincidence, but others admitted the alignment was too exact to overlook. The perihelion window. Every orbit has a single point when an object reaches its closest approach to the Sun. This moment is called perihelion. It marks the time when an object swings inward before being sent back towards the distant reaches of space. For the object named 3I Atlas, this moment had been carefully calculated. It was predicted to reach perihelion on October the 25th, 2025, at precisely 11:36 Coordinated Universal Time. From the perspective of observers on Earth, the comet would pass directly behind the Sun at that instant. The Sun's intense glare would make it completely invisible to all ground-based telescopes for several days. No observation could penetrate the overwhelming brightness. Every attempt to see it would be washed away. In the study of orbital mechanics, this is a routine event. Objects pass behind the Sun regularly, and temporary invisibility carries no particular significance. It is simply part of the natural rhythm of celestial paths. But in the case of 3I Atlas, the circumstances felt different. The object had previously displayed movements that resembled deliberate adjustments, as though it were controlling its own course. This made the timing of its perihelion feel almost purposeful. The alignment created the perfect window for any significant change in trajectory to go unnoticed. Spacecraft often exploit similar opportunities when they wish to alter paths without detection, using the Sun's glare to mask their maneuvers. At perihelion, the Sun's gravitational pull strengthens, making it the most effective moment for modifying a path. Even small movements can produce large results because the Sun's gravity amplifies them. By the last week of October, the path of 3I Atlas had changed so dramatically that computer models could no longer agree on its exact location. One forecast suggested the object was bending slightly inward, drawing closer to the Sun. Another predicted it was veering outward, rising toward Venus's orbital plane. The actual position seemed to fall somewhere between these predictions, as if the object were choosing its direction as it moved. Its behavior made precise tracking extremely difficult, even with advanced technology. As perihelion approached, the comet exhibited even stranger characteristics. Instead of brightening under the Sun's increasing heat, it continued to dim. This defied basic expectations. Comets normally shine more intensely as they near the Sun because solar heat vaporizes their material, creating a glowing coma that reflects light. The mathematical echo of 3I Atlas. While 3I Atlas was hidden behind the Sun, strange effects began appearing in the computers that continued tracking it. Observatories in Europe and Japan started noticing faint irregularities slowly spreading through their data streams. Figures that were expected to behave randomly were shifting in coordinated patterns, almost as if they were following a rhythm that had no natural explanation. The systems were not detecting light or physical motion. Instead, they were picking up a fine type of behavior that did not match instrument faults or typical statistical noise. The first warnings emerged inside the telemetry logs. These logs began showing repeated computation failures, not because any device had malfunctioned, but because the numbers being received were producing outcomes that were mathematically impossible. Solar monitoring satellites soon returned data packets that carried duplicated sequences. The code inside these packets appeared mirrored, with identical information written twice in slightly altered forms. Error correction software attempted to repair these differences, but could not reconcile them at all. Every time the systems tried to align the mismatched figures, the corrected results collapsed into further inconsistencies. What made the situation even more compelling was that the timing of these digital disturbances matched perfectly with the last projected path of 3I Atlas. The alignment reached down to fractions of a second, making the coincidence extraordinarily difficult to dismiss. Computational physicists who studied the corrupted data described the effect as non-causal. In simple terms, the instruments tracking the comet were producing final outputs before the internal computations required to form those outputs had actually finished. It looked as if the calculation itself was skipping ahead of its own steps. One researcher compared the behavior to quantum entanglement, where paired particles share information instantly, even when separated by enormous distances. As specialists continued discussing these anomalies, a new phrase began appearing in private scientific exchanges. This idea suggested that the comet's positional information was not behaving like ordinary orbital data. Instead, it behaved like one fragment of a much larger calculation, and tiny pieces of that larger process were leaking into the networks attempting to measure it. The more researchers examined the patterns, the more the concept seemed to fit the unfolding evidence. Once the sun's glare began to weaken and normal observing windows reopened, disagreements across the scientific community became much sharper. Some argued that 3I Atlas had most likely dissolved after being exposed to extreme solar heating. Others believed it had shifted into a state that present-day instruments could not properly describe. However, the teams that had watched the digital disruptions most closely believed something entirely different was happening. To them, the object had not vanished. Instead, it had interacted with the mathematical systems used to track it, forming feedback loops between its real movement and the digital predictions designed to follow that movement. When telescopes finally regained a clear view and were pointed back toward the coordinates where the comet was expected to reappear, they recorded something completely unexpected. 3I Atlas returned, but it did so quietly, slightly displaced, and following a path no model had predicted. It was moving faster than before, shining with a softer glow and drifting off its earlier orbital plane. It looked as if it had undergone a controlled transformation while concealed behind the sun. Final measurements showed it had shifted its route by more than 2 million kilometers. This modification was far too exact and far too large to dismiss as a natural reaction to solar forces or dust outgassing. Whatever occurred behind the sun, the comet emerged following patterns that resembled deliberate engineering rather than ordinary celestial behavior. Its light stayed narrow and concentrated, pulsing every 12.7 seconds in a steady rhythm. The pulses were not random. They appeared measured, almost like a signal. If you enjoyed this video, like and subscribe, and also click the next video shown on your screen.